Okie dokie. Question 7. F of x is 16 over x, and L is the tangent line of f at x equals 8. And it wants you to find the gradient of that. So first of all, let's get the derivative, because remember, gradient is slope. So we're going to rewrite this. F of x is 16 x to the negative 1. Then f prime is going to be negative 16 x to the negative 2. And then we're going to plug in 8 there. So f prime of 8 is going to be negative 16 over, well, 8 to the negative 2, which would simplify. You'd get 16 over 64, which simplifies. You guys can divide at a bunch of 16ths, and you get negative 1 over 4. So the slope at the gradient at L is going to be negative 1/4. Okay. Then it's saying L can be expressed in the form. So this is now vector form of an equation. So you got to think back, because it's been a while, but remember, the IB loves mixing things together. 8(2) plus TU, and it wants us to find U. Well, this form is not super different than like mx plus b, except in this case, it gives you a vector that you're starting with, and it is that U that is the direction. So if we're going to have a direction of negative 1 over 4, then what I want to do is I want to go over 4, and I want to go down 1. So the vector, right, because this is going to give me, so it's like a negative 1. This is going to give me the direction that I need of negative 1/4. And so the vector I want for that would be the vector 4, negative 1. Or any scalar multiple. So if you wanted to, you could do a negative 4 and a positive 1. You could do 8 and a negative 2. Any other multiplier of this, and you should be good. Okay. 7C. The direction vector of xy is 1, 1. Sure, that's true. And then it says find the acute angle between xy and L. So let's first of all get a picture of this in our brains, because I think that might help. So the xy, let's do that in orange here, is just 1, 1. So this is x equals y, right? There's that line. And it's, got the direction of 1, 1. And then the vector here, which is, it starts off at 8, negative 2. So you'd go like over 8 down negative 2. 8, negative 2. And it moves in the direction of 4 over negative 2, which is great because that actually works really nicely for us. And it's looking for what this angle is right here. And so you're actually going to go back to a bunch of vector stuff. If you look on page 8 in your formula booklet, that's where you're going to find all of this. And what we're going to be doing is we're going to be taking this vector, well, actually, I think I'm going to use this one and the vector 1, 1, and we need to apply this formula. Now, this is what's written in your booklet, but since we're just dealing in 2 dimensions, you only need, you don't need that last bit. Like, we're going to get rid of that because it doesn't actually matter. The numerator right here, it is the scalar product. So what we're going to do is we're going to take 4 times 1 plus negative 1 times 1, which would give us 3. Over the length of the vectors, which if you're not sure and you don't remember what this is, you can actually kind of suss it out by looking at the formula booklet. But it's just like, again, here, if we're looking for the length of that vector, and so you're going to have 4 squared, 1 squared, 16, 17, so it's going to be the square root of 17, and then this one's going to have the square root of 2, so you're going to have this over the square root of 2 times the square root of 17, and then you're just going to do the inverse cosine of that, and then the inverse cosine will get you about 120.96 degrees, but we're looking for the acute angle, which means you're just going to take the complement of this, so 180 minus 120.96, and you are going to get that the angle is about 59 degrees. Or if you wanted to convert it to radians, it's like 1.03 radians. Same idea. Whew, buddy. Okay. Next one says find the composition of the function with itself of x. So we know that f of x is 16 over x. And basically what you're going to do is you're going to replace that with 16 over x. So you're going to end up getting 16 over x, which you could then rewrite as 16 times the reciprocal, or x over 16, and then these guys would simplify, and you just get x, which is good because we're supposed to get that. And then it says, please write down the next bit, the inverse of x. Well, what you're doing really is when you ask for the inverse, you're flipping your x and your y's. But if you simplify this and we just kind of show that this is what's going to happen when we end up doing this, you're going to end up getting that y is just 16 of x. So this function is the inverse of itself, and this is, for 7e, the inverse of x. And then it says, please find the obtuse angle formed by the tangent line to f at x equals 8 and the tangent line at x equals 2. Well, the function is symmetric about the line x equals y, just because all functions that are inverse like this end up being symmetric about that. So just to get an image of what we're after here, somewhere over here is going to be 8. There's that, and we're going to have a tangent line at 8, something like that. And then somewhere over here, we're going to have 2, and we're going to have a tangent line at 2. And what we're really looking for right now is this angle between those two tangerine colored, I guess, tangent lines. So it sure would be helpful if we had direction vectors for each of them. Well, from above, we already have the direction vector for this one right here. We know that that direction vector is -4, 1. So this one has a direction vector. Yikes. What color should I use? Okay, that one. The tangent line at x equals 8 has direction vector for -1. And we need to make sure that we have a direction vector for over here. Reasonable way to do that is to just plug in 2 for the function, the derivative. So we'd get -16, 2 to the -2. This would get us -16 over 4, which would get us -4, which means that we basically have the direction vector here of 1, -4, because it's going to be over 1 and then down -4. And so you're just looking for what is the angle sitting between these two. And because they gave us this thing for a reason, right? Didn't they? That's where your symmetry bit comes in. If we know that the angle here is 59 degrees, then we know that, sorry, what I mean by that is this is 59 degrees. Because of symmetry, we know that this one's also going to be 59 degrees. You can double check it by literally calculating the angle between these two using the exact same cosine formula we had up here. Or you can just say, aha, I see symmetry. They gave me all of that for a reason. And your answer for 7F is going to be 59 times 2, or 118 degrees. Whew boy, that was a lot. Pulled on calculus, pulled on vectors, pulled on all of the things. Let me know what questions you have. I'm super happy to help you out with it.